Hello and welcome to episode 1 of the Blockchain Interest Group podcast with your hosts Krishna and Nikhil. BIG is a consortium of individuals who are interested in blockchain and distributed ledger technologies. You can learn more about us on our website big-org.com or follow us on our social media using the links in the description down below. I am Krishna. I'm an electrical engineer by trade working in the alternative energy industry. The first time I looked into blockchains was in 2015. Found it to be pretty groundbreaking and have been interested in it ever since. Nikhil, do you want to tell our audience a little bit about yourself?
Sure. So I'm Nikhil. I've been in the software development space since the turn of the century. I got the blockchain bug early last year when I read the Satoshi white paper, and I kind of fell in love with the technology and the algorithm. Been a passionate follower of the space ever since. So we are taking the topic of IOTA today for our first podcast, and the irony of it is the IOTA is not even a blockchain. So if you actually look into IOTA, it's a pretty interesting piece of technology. So Krishna, could you just go into what is IOTA?
Sure. So IOTA is a cryptocurrency among the sea of many cryptocurrencies that are in the market today. But how it really distinguishes itself is that it's a cryptocurrency which has been designed specifically to be the backbone of the Internet of Things industry. So the IoT in the IOTA stands for Internet of Things. The very first aspect of IOTA, which makes it very interesting, is that it claims to have zero transaction fees. So unlike blockchain technology, so if we were to take an example of Bitcoin or Ethereum, where you have two separate entities in the network called the users of the network and the miners of the network. IOTA has no such distinction between its users. Every user effectively is a user as well as a miner at the same time. So this, in a way, allows IOTA to carry out transactions without any transaction fees being charged anywhere in the network. So we will be going a little bit more into the details of how this is achieved and how this is possible. The second thing which I would say made IOTA really popular is its claim to be quantum computing proof. So to take a deeper dive into the technology that underlies IOTA, it would be good if we can compare it with what already exists in the market, which is blockchain technology. Nikhil, could you elaborate a little bit about what is blockchain technology and what is IOTA's technology and how the two are different from each other?
Sure. So the majority of the cryptocurrencies and blockchain platforms out there actually are built on this concept of the blockchain, which was the original groundbreaking idea behind the Bitcoin, right? So the blockchain can be considered to be a data structure. So it is a specific, very simple data structure where it is essentially a cryptographic linked list where uh, the current block or the current link in the chain basically has a hash of all the previous links in the chain, and which makes this particular data structure unique and very hard to change, right?
Mhm.
But IOTA actually takes a very different approach to that underlying data structure it has, right? So in general, IOTA works in the following way. Instead of a global blockchain, there is what is known as a DAG, or a directed acyclic graph. They call it internally, IOTA calls it a Tangle, right? And transactions are issued by nodes that constitute the side set of a tangle. So a tangle graph, essentially, the tangle essentially is the ledger in which these transactions are stored. Now, they have certain terms in IOTA, so it's useful to think of a transaction as a site on the Tangle graph, right? So site essentially is one transaction. Again, that's the difference between IOTA's Tangle technology and blockchain, in the sense that blockchain usually takes a block of transactions, multiple transactions, and puts it together as a block, whereas in IOTA, every transaction is a site, right?
Right.
It's a site.
Right.
And
So if I could just add to that, so basically in a Tangle technology, which where the public ledger is a DAG, which is a directed acyclic graph. Unlike a blockchain system where your public ledger is actually a chain of blocks, each site in that public ledger is an individual transaction. Is that correct?
That's right. That's right. There is no grouping of transactions per se. It's basically every transaction is a site on the Tangle, right?
Sure.
Then obviously the other thing in IOTA in terminology is the concept of a node. A node basically is a participant in the network. It can be considered the user that is actually creating the transaction. So that is the other piece of terminology. So you have nodes, you have the sites, and a group of sites called the Tangle, right?
Sure. So just to give this a little bit of perspective, so when we talk of nodes, I guess we are meaning individual IoT devices in the IOTA network. So that may include my smart coffee table, that may include my self-driving car sometime in the future. So I guess that's what we are referring to as nodes. Could you just give our audience a brief rundown of what a practical use case of the IOTA network would look like, and what is the advantage of using IOTA over existing blockchain technologies like Bitcoin and Ethereum in such a IoT scenario?
Right. So when you talk about Internet of Things, right, you're talking about a network of devices, right? So fundamentally, basically, if you look at it, the network of devices actually is useful when they can communicate with each other and they can exchange transactions with each other. So IOTA actually fundamentally wants to be the platform on which IoT devices or these small devices can actually perform transactions with each other, right? These transactions can be anything from an MQTT message to a SMS or some other kind of message. Essentially, it is a transfer of value in terms of the IOTA token and an instruction set along with that, right? So how this is different from a blockchain, essentially, is this thing is that, so if you go back to what when Krishna earlier referred to as the fact that there is no demarcation in IOTA between a miner and a user. It essentially what he said was that the user is also the miner, correct?
Right.
So in IOTA, basically, if a particular device wants to actually add a transaction to the IOTA Tangle, what it needs to do is it needs to approve two other transactions. So that's the work that it does, right? It adds, in addition to adding its own transactions, it basically marks or validates two other transactions and says, yeah, these are valid transactions, right?
Right. So I'm guessing that effectively acts as
You're
uh,
mining.
your mining. Like that is the work you're doing for the network to even be a part
Well,
of the network.
and that's the majority of it. There's also one additional part, mainly to prevent spamming the network. So there is a small proof of work that is done, which is actually a lot less intensive than the proof of work that is done for Bitcoin and other such Ethereum and other such technologies. It is a very lightweight proof of work, mainly to make sure that there is a cost associated, uh, in terms of CPU time when you add a transaction, just so that you cannot have the device basically trying to spam the network with millions of transactions without any cost.
Sure. So effectively, I guess this acts like some sort of a captcha. So it's basically a deterrent for spammers. It's not going to completely stop spamming, but it would associate some cost with it so that it's not feasible. Would that be right?
Exactly.
Okay.
Exactly. So, so this actually now goes into how basically IOTA works. IOTA basically, as I said, is a directed acyclic graph. So, unlike a blockchain, it is not a linear. It is not a linear entity. It is a two-dimensional tangle with a lot of different connections between each other. It's a graph, and so there's a set of algorithms and a set of rules around how you determine a valid transaction and how basically transactions are added to the particular tangle. Krishna, maybe you want to elaborate a little bit on how IOTA works, the weights and the scores and the tip selection algorithms?
Sure. So at its most fundamental level, I would say each transaction has certain attributes in the IOTA network. Each transaction has what is known as a weight, its own weight. So a weight is basically a number which is allotted to every transaction, depending on, roughly speaking, I would say it depends on how important the transaction is. So if you look at the IOTA white paper, they go into the details of the mathematics behind it. The own weight of any transaction is in powers of 3, as per the white paper. So for example, a transaction which is very low in priority, might have a weight of 3 raised to 0, which is 1. At the same time, a transaction which is a little bit more important, which is probably of a higher value, will have a higher weight. So it might be 3 raised to 2, which is 9. So IOTA basically uses a system where there are two main attributes. One is the weight, and second is something called the score. It uses these two attributes to determine which is the most valid branch in the tangle.
So if you go into like we were talking about, how users add transactions to the IOTA tangle and all that. So there is obviously a set of algorithms and a set of rules as to how transactions are added and how you may ensure, how you find out if a transaction is valid. Correct. Mm-hmm. So essentially, when you validate a transaction, basically, you are actually looking at the weight of the transaction. So there is this concept of a weight, there are scores, and there is a tip selection algorithm. So before we got into what is the tip selection algorithm, we need to first understand what is a tip. The tip of a tangle essentially is the bleeding edge, the edge where actually transactions are being added. So you can actually conceptually look at the tangle graph as a graph that starts with the genesis block on the left and kind of grows into this complex tree towards the right? And you have a leading edge on the right where transactions are continuously being added by all these devices, right? Mm-hmm. And that is known as the tip of the tangle. And the idea essentially is that you want to select the right transactions on the tip in order for you to validate that, right?
Right. So I'm guessing the tips would be those transactions which have just been added to the network, and exactly. I guess they have approved 2 transactions as the rule of the IOTA network specifies, but they are yet to be approved by any other transaction. Is that correct?
That's essentially right. Okay. So I have added a transaction to this to the tangle, right? So in doing that, basically what I have done is I have validated or added my vote, saying that transaction A and B are valid transactions, and myself at transaction C, as a consequence of that validation, has been added to the tangle. Okay, so when I have added my transaction to the network, I have actually a particular weight, right? That weight basically is in powers of 3. So my current weight would be 3 raised to 0, which is 1, right? And since I have added my vote to transaction A, assuming that no other site, no other transaction has also validated transaction A, the weight of that particular transaction becomes transaction A becomes 3 raised to 1, which is 3, right? And so similar case for transaction B.
So I guess the cumulative weight would be the own weight of a transaction plus the own weight of transactions that are validating this transaction as well. Like I guess there's a concept of direct validation and indirect validation as well, right? Could you just go a little bit into that?
Sure. So that's very correct. So essentially, so like I was saying, weight, the cumulative weight of a transaction, like you very correctly pointed out, Krishna, is the weight of the transaction itself, and in addition to that transaction, basically the cumulative weight of all the transactions that validated either directly or indirectly. So by indirectly means it, what I mean is that if I am a transaction A and I have been validated by transaction C, and then in turn transaction C has been validated by transaction D, then I basically as transaction A have a cumulative weight of myself as well as transaction C and D, even though D did not directly validate me.
Sure.
Transaction which
So,
in turn validated me,
mhm.
right?
Okay, sure,
So
makes sense.
so that basically means it kind of implies that as your Tangle grows, right,
Mhm.
your transaction becomes heavier, and in this particular case, the weight basically determines the level of confidence that this transaction is valid.
Right.
Right?
So another way of looking at this would be that the older transactions in the DAG would
Uh-huh.
higher cumulative weight as the network becomes bigger and bigger.
That's
Right.
correct. That's correct.
Okay.
Right.
Okay. Can you just tell our audience again the significance of cumulative weight, and like there's also something called a score, and like how the two differ?
Right. So a score basically is considered to be the distance from the uh, Genesis block, or rather the Genesis transaction, right? So
So Genesis transaction is the very first transaction in this DAG,
that's correct. So
right?
the first transaction in this DAG, and so basically what you do is you create an unbroken line, from transaction to transaction, that connects your transaction to this Genesis transaction, and the number of hops basically gives you the score,
Right.
right?
So basically, you look for the longest path to the Genesis transaction, and you just
Exactly.
add up those weights, I'm guessing.
Yes. So essentially, you add up those weights and you get what is known as the score of the transaction. So
Mhm.
in terms of the weight is basically all the nodes that are validating you, whereas the score basically is the distance that you are from the Genesis transaction, right?
Sure, sure.
So so that is
So,
basically these two rules that we have in terms of finding out which are valid transactions, and which are transactions that are safe to be, and taken as valid.
mhm. So I guess like in the white paper, it talks a little bit about the tip selection algorithm. And I guess the cumulative weight and score, they have an important role to play in terms of how to select the tips. And again, for the audience, tips are the very new transactions that have just been added to the network, which have validated two other transactions but are yet to be validated by another transaction. So I guess that's where the relevance of the tip selection algorithm comes in, right?
Correct. So so basically the tip selection algorithm needs to be something that is lightweight, as since again you're talking about a device that is not very CPU. It's not a very powerful CPU or anything, and you need something that needs to be fast, because you obviously want it to be seamless as possible, right?
Mhm.
So the reference algorithm that is used by the uh, uh, by the IOTA network is known as the MCMC algorithm. So it
Mhm.
is a Markov chain Monte Carlo algorithm. So essentially, what this is what this does is basically it places some kind of particles on different sites on the tangle, and then lets them randomly kind of walk towards the tips in a random manner. So essentially, it's like saying, okay, kind of falls down in a particular in a random way, and
Mhm.
then when it finally reaches the edge or the tip, that transaction basically can be selected as the transaction that you want to validate.
Just to
Right?
add one more
So,
point, like one of the things that I saw in the white paper regarding the tips was that the goal of the IOTA network, or the goal of stability, as it's mentioned in the white paper, is
mhm,
to maintain a somewhat constant number of tips. One way to look at it is that if you have a set of new transactions that are being generated in the network at a constant rate, at
right.
any given time, your goal would be to have that number of tips not fluctuate too much for that system to be stable. Could you just tie in that into what is the relevance? Like how are you able to maintain uh, a constant number of tips or somewhat stable number of tips so that the system does not become unstable?
Right. So the idea essentially here is that you don't want so many tips that are not valid, that actually could result in splitting or uh, orphan tips and things like that. So what you want to do is you want to keep your tangle to be a narrow graph. There are two scenarios basically, where you have what is known as a low load regime, where you have a few tips being created, and basically those tips are immediately validating or validated by other transactions that come in. The other option is the high load one, where the typical number of tips are very large, and if the flow of transaction is big enough, then it will basically result in a lot of tips that and the chances that the same tip is approved by that the several different transactions approve the same tip, right?
Mm-hmm.
So this is something that you don't want to do. It's a wasteful thing. You need to move the tangle forward, and if all of them are actually approving the same tip, this is actually because obviously other tips in the tangle are not getting approved, right?
Right, right.
So in a high load regime, what typically should happen essentially is that the device basically submits a transaction, right?
Mm-hmm.
And it does not make it to the top layer. It doesn't get approved very quickly.
Mm-hmm.
Then the chances of it getting approved become lesser, because essentially what the random walk algorithm would do is that there is a weightage to it, so it will take the higher weight tips up first, and then go down the ones that are validating that, and that particular it leads to a situation where your transaction might fall uh, into a kind of a branch or a orphan block, right? And
Mm-hmm.
then you don't have a transaction. You don't have anybody validating. So the strategy for that basically would be to issue an additional empty transaction referencing the first one. So in increasing the weight. So this is just basically a blank transaction. And then again, you have the same constant probability that this new transaction would have to be would be approved, right? And so the idea is, as a strategy, would basically be to just keep promoting with your empty transactions, to make sure that your transaction falls in the higher probability area of getting approved, right?
Mm-hmm.
So you have a situation where you have possible attack strategies that might come back, where you do basically try to add a lot of weight onto your own transaction in the hopes of getting priority in being approved by other other people in the network.
Mm-hmm.
And so that actually leads to a situation where you might get into attacks where you do double spending attack and the other thing other
Right.
so-
Sure. So actually, yeah, that brings us to the the main big question with regard to how IOTA differs from blockchain is, so where is the ledger stored? Case of blockchain, you have a copy of the blockchain being maintained on every node. But in this case, since all of the IoT devices, I guess they have a constant IOTA chip with a pretty low memory and storage. I'm guessing the storage would happen elsewhere, and I think that's where this concept of coordinator nodes. Is that something you can elaborate on?
Sure. So coordinator nodes basically, so they're actually something that have been added into the IOTA network by the folks behind IOTA, right? So the company that is promoting IOTA, and it's not there in the white paper or in the the conceptual or theoretical model of IOTA. But coordinator nodes essentially are considered to be kind of like training wheels to be kept over there, placed in as kind of like an initial stage to kind of seed the network. But okay, so the concept of a coordinator node is essentially a node that does nothing but create snapshots, right? So it basically takes the current state of the IOTA network and creates a snapshot by compressing and grouping things together, and pruning, not exactly pruning, but kind of putting together the valid nodes, and creating a kind of a reference point from which the devices can actually choose to go ahead. So this is important because obviously IOTA devices have low memory in addition to low CPU, and they cannot host the entire IOTA tangle within themselves. And so how do you do a validation? So they basically will typically take a snapshot as a starting point, and just consider the tangle growth that has happened since that last snapshot.
Sure.
Okay?
So I'm guessing the devices would, at any given point in time, capturing the state of the network around them, the transactions that they have been interacting with, and this data would be given to the coordinator nodes, which are distributed all over the network, I'm guessing. And I think
True. So
that
coordinator nodes also, we really very recently found out, have another verification functionality where they actually do another round of validation to make sure that transactions are kosher, and essentially they basically once your transaction gets into a snapshot, you're kind of like, okay, now it's been approved by the whole network completely.
Mhm. So the basic purpose of this is to store a complete copy of the DAG, which would not be possible without such nodes, correct?
Yes, yes.
Okay.
So they in future, then their roadmap, they talk about light clients and light nodes and sharding and things like that. But again, there's not that much clarity into how that's going to happen and what is the way they're going to do that.
Sure. So I guess one of the recent controversies, which I think IOTA ran into with the team at MIT, was a bug that the MIT team had found. I guess that it had something to do with uh, the hashing algorithm that IOTA was using.
Right.
Could you tell us a little bit about what that whole thing was?
Right. So basically, this all started with a Medium post by a lady named Neha, who is the director of the MIT Media Labs cyber security team or something. So it basically talks about a cryptographic vulnerability in IOTA in a particular hashing algorithm that was created by them called curl-p. Rather, that's what IOTA internally calls that hashing algorithm. Essentially, so essentially the problem basically there was, well, first of all, hashing or cryptographic hashing basically is something that is a bit of an art. So there are very few algorithms out there that are provably safe, and it's quite hard to actually find one that can withstand all the possible types of attacks that are out there. And there is actually a standards institute known as the National Institute of Standards that actually uh, goes ahead and every few years basically looks at the current state of the art in terms of cryptocurrencies and, sorry, not cryptocurrencies, cryptography and the algorithms, cryptographic algorithms, including hashing algorithms, and proposes designs as well as creates competitions for implementations of this design, and does a lot of very rigorous testing. So when this particular team, Neha's team, basically at this particular hash function, they it is a custom hash function. They actually did what is known as differential cryptanalysis, right? And they found a vulnerability over there where you could get a collision. So what is a collision? A collision basically is when a particular hash can be made to represent two particular inputs. So one of the fundamental properties of a hash or a cryptographic hash is that given a particular input X, the hash of that particular input X is unique. So there cannot be any other input Y that can actually hash to the same value as the hash of X.
Sure.
Okay. So if that actually happens, that's known as a collision, right? So not only were they able to find easily find collisions, they also found a way where basically a transaction that is signed by one person. So when Alice signs a transaction and gives it to Bob, using that particular signed hash, they could then generate a separate transaction, valid transaction, where the number or the amount, say for example, Alice is hashing a signature of a transaction that is doing 1 IOTA to Bob, right? And that comes up with a hash. They found a collision hash where basically the same transaction is happening, except that Alice is now handing a considerably larger sum of IOTA to Bob.
Sure.
Okay, so this is obviously a problem, right? So now you are actually you've got two valid transactions doing two different things. So
right, and this collision, if I could just add, so this collision happened because the IOTA team used their own hashing algorithm called curl P. And is there a reason why they did not stick to the standard SHA-2 system?
So this is where the controversy comes in, right? So essentially, so they found this and they submitted it, and they talked to apparently they talked to IOTA about it. And IOTA, there is a programmer called Come From Beyond, Russian guy. I just remember his Come From Beyond. He's one of the bigger names in cryptocurrency space. He has been working on other cryptocurrencies before this. He basically told them that it was an intentional thing, right? So his position basically is that when they released the IOTA source code as an open source project, right? They also released a curl P function, and they intentionally kind of crippled the curl P function, kind of, so that people who clone or try to use the same code in their projects would have this particular vulnerability, and that the curl P functions utility was not actually the validation of the transaction is not actually happening at the point the transaction is added. but it was happening in the coordinator node that we had spoken of earlier, right? So he said that this coordinator node which has kind of closed source software. The software for the coordinator node is closed source. It's not available for inspection. He said that that particular software actually had the validation, the true validation that is done to make sure that collisions and bad transactions like this cannot be added to the IOTA network. Okay, so this actually leads to two, obviously, more questions than it answers. Anyway, they responded to the specific attack that Neha and her team pointed out, and they actually developed yet another function called KEKAK, apparently CKEK, which essentially uses a variation on which essentially uses this SHA-3 algorithm internally.
Okay.
So apparent that particular area has been fixed, but according to MIT, that curl P is still being used in other places in the software, and they recommend that all of those be changed as well, patched as well. But anyway, the whole thing, devolved into a kind of like a pointing game and accusations of other people being told before it became public and all that. So, I mean, it all depends on your perspective, I guess, but personally, leaves. If you ask me, I think the IOTA team could have done a better job handling that.
I guess that raises an important point. I mean, IOTA is a pretty big project. It's a $1 billion plus project at this point. So I guess one of the challenges that this industry as a whole faces is uh, there's probably not a lot of vetting process that goes on initially. There's not a lot of code review. I guess this is one of the challenges that the entire industry is going to face in the coming months or years.
Well, slightly different opinion on that particular aspect of it. See, as a software developer, I am aware that we all make mistakes, and I would never totally depend on an initial review, because look at it that way, you can take the most famous bug that has happened in the crypto space, bug that happened on the DAO, which is that distributed autonomous organization on Ethereum. That bug basically happened despite a so-called security review happening on the code, right? So it was actually supposed to have been vetted by security experts and given a green light, and they pointed out issues, and those issues were addressed, and still it got hacked. So I don't think it's realistic to imagine that everybody will get it right the first time, and that all software would be uh, perfect the first time. But that is one of the reasons why I feel that open sourcing software has so much more value, in the sense that it allows people like Neha and her team, and other crypto security researchers to actually subject the code to the deeper, longer critical research that they require, right? So if you close source your code, that particular opportunity is lost. You don't have that many eyes looking at it, and you might hire the best security team in the world, but that's still going to be less eyes than what could potentially be happening in if it was open source. So one thing is that particular aspect. Second aspect is that you should all these companies, cryptocurrencies, should actually come up with a a plan of action for the inevitable time when there will be some kind of bug or some kind of issue that has been either reported or subjected to. Because to close your eyes and say that okay, it's never going to happen is unrealistic. and there should be in terms of insurance policy or some kind of risk mitigation.
So as a last note, what is your general opinion about IOTA as a whole?
So, notwithstanding the security issue and vulnerability and its and the way it was handled, I am still on the whole quite bullish. I'm quite happy. I'm quite excited by the technology. I think it has a lot of potential. There are still quite a few areas, in my opinion, or in my limited understanding of it, that I'm not fully clear about, and I anticipate would come out in as the roadmap matures, and we go and start using this in real life. As far as the concept or the idea of this particular different way of addressing the Bitcoin or the blockchain problem, quite excited. I think it has a lot of potential, and people should continue to give it a chance.
All right, folks, thank you for joining us on the Big Podcast. Hope this episode on IOTA was useful to you. Please leave us your comments below. Also, we have a very active Telegram group. Should you wish to join, the link is in the description below. Thanks again for joining. See you next time.
Bye.